Hello and welcome friends. In this new video we will discuss about an integrating factor. Friend, you are familiar with the exact differential equation. In the previous video on differential equation we have seen that what is meant by exact differential equation. But what happens sometimes the equation is not exact. It will be converted into exact differential equation by using some multipliers, and that multipliers are called as a integrating factor. When we choose such a term which when multiplied to equation, that will convert it into exact differential equation, and such a factor is called as an integrating factor. There are some rules to finding a different integrating factor. Friend, as I have told you in the very first video, there is not a unique method of finding and finding solution of an differential equation. Therefore we have various different methods of finding a solution of differential equation. Integrating factor is also useful to convert an differential equation into an exact differential equation, and which we can solve by using the method of an exact differential equation. Here see what is the definition of an exact differential equation. So any factor any factor any factor which changes which changes which changes an equation an equation an equation into an exact differential equation exact differential equation exact differential equation is called an integrating factor is called as an integrating factor. So this is the definition of an integrating factor. Here let us see y into dx minus x into dy equal to 0. If we compare this, m dx plus n dy equal to 0, we get m equal to y, n equal to minus x. Now let us differentiate this. Del m by del y equal to 1, del n by del x equal to minus 1. So here del m by del y is not equal to del n by del x, and hence this equation is not an exact differential equation. But whenever we multiply by 1 divided by y square, let us multiply this equation, multiply by 1 divided by y square. You can see that 1 divided by my y square, this will be 1 divided by y into dx minus x divided by y square into dy equal to 0. You can see that m equal to 1 by y, n equal to minus x divided by y square. Then let us calculate del m by del y equal to minus 1 divided by y square, del n by del x equal to minus 1 divided by y square. So the given equation is converted into an exact differential equation by a term simple by multiplying simple terms 1 divided by y square. Now print how I have decided to multiply by 1 divided by y square. This is method of practice. By practice we can decide, or we can choose and term when that multiplied to the given equation will gives us an exact differential equations. Also there are rules, there are few rules which gives and exactly how the integrating factor, how to find an integrating factor. But by inspection we can by solving various equation, by practicing, by inspection, then by inspection we can find an integrating factor. Now here we have some rules of finding an exact integrating factor. So among the various rules we will see a first rule of finding an integrating factor. The rule is a very simple rule. First, what is the rule? Rule first you can see here, uh, del m by del y minus del n by del x divided by n is a function of x alone. Whenever this term del m by del y minus del n by del x divided by n is contains only terms of x, then 1 divided by this function, then integrating factor equal to e raised to integration of f of x. That term, that function is an integrating factor. Okay, so let us see a simple example of this rule. Solve 2x into log of x minus xy into dy plus 2y into dx equal to 0. This is an simple example. Here you can see that mdx plus ndy. M is what? M is equal to 2y. What is n? N is equal to 2x into log x minus xy. Now del m by del y is equal to 2. Del n by del x equal to del n by del x, first function, that is 2x, so derivative of 2x is 2 into log x plus 2x into derivative of log x 1 by x minus xy, minus y is constant, so derivative of x is y. And you can see that this x will get cancelled, and we have this is equal to 2 common, we get 1 plus log x minus y. Let us take del m by del y minus del n by del x equal to 2 minus 2 minus 2 log x and minus y, minus y. 2 get cancel, and this will be minus 2 into log x minus y. Now del m by del y minus del n by del x equal to minus 2 log x minus y whole divided by n. Let us calculate this. Divided by n, what is n? 2x into log x minus xy equal to you can see here this is equal to minus common 2 into log x plus y divided by here we can take x common, and when we take x common then So here minus 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 minus, so here we have missed something. This will be plus, minus minus become plus, so this is plus and this is get minus. Then you can see that here 2 into log x and minus y, 2 into log x minus y, 2 into log x minus y will get cancel, and we get 1 divided by minus 1 divided by x. Then what is integrating factor? This is my f of x, this is f of x. Integrating factor equal to integration e raised to integration of f of x minus 1 divided by x into dx equal to e raised to minus log x equal to e raised to log of x raised to minus 1 and equal to 1 divided by x. And here we have an integrating factor 1 divided by x. So let us multiply by this factor and let us see what happens to this new term of this equation. We have obtained an integrating factor. Let us apply that integrating factor to multiply this equation. This is my equation, so let us multiply by 1 by x. Whenever we multiply by 1 by x, you can see that this x we can take common and cancel, and we get 2 into log x minus y into dy plus 2 divided by 2y divided by x into dx equal to 0. Now friend, let us see what is new m and new n, whether the given equation is converted into exact or not. We will check whether this equation is an exact equation or not. Okay, so first let us find value of m. Value of m, new value of m is here, m equal to 2y divided by x and n equal to 2 into log x minus y. Then del m by del y is equal to 2 divided by x, del n by del x, del n by 2 divided by x. Now this equation is an exact. Then what is the solution? Then we know that solution is integration of m into dx plus integration of n, n not containing, means those terms of n not containing x into dy equal to c. Integration of m, 2y divided by x into dx plus integration of those terms from n that do not contain x. So this is my n, here this is my n, this term contain x, so leave this term and take only this term. So minus y into dy equal to integrating constant c. You can see that 2y is constant, and integration of 1 by x is log of x minus y square divided by 2 equal to c. This is the solution of this equation. Okay, right. So let us see the next rule for finding the integrating factor. This is the one rule. This is very simple rule. Similarly, second rule is also very simple. What is that rule? If del n by del x minus del m by del y divided by, here m is function of y alone. Whenever this is a function of y alone, suppose if f of y, this is my function, that function, then integrating factor is e raised to integration of f of y into dy. This is a integrating factor. So let us see an example of this. Set y raised to 4 plus 2y into dx plus uh, x into y cube plus 2y raised to 4 minus 4x into dy equal to 0. In this equation, my m is y raised to 4 plus 2y and n is x into y cube plus 2y raised to 4 minus 4x. Then del m by del y equal to 4y cube plus 2, derivative with respect to y. Del n by del x equal to y is constant, so derivative of x is 1, y is constant, so derivative is 0 minus 4. This is the del n by del x. Now let us calculate del n by del x minus del m by del y. This is equal to you can see that y cube minus 4 minus 4y cube minus 2 equal to what we get here, minus 3y cube minus 6 equal to minus 3 common y cube plus 2. This is an del n by del x minus del m by del y. Now del n by del x minus del m by del y divided by m whole divided by m equal to minus 3 y cube plus 2 divided by what is m? M is y raised to 4 plus 2y minus 3 into y cube plus 2 divided by, let us take y common, y cube plus 2, y cube plus 2, y cube plus 2 get cancelled, minus 3 divided by y. So here integrating factor equal to e raised to integration of minus 3 divided by y into dy. This is equal to e raised to minus 3 into log y, or this is equal to y raised to minus 3 or 1 divided by y cube. This is an integrating factor. Now let us apply this integrating factor to convert this equation into an exact differential equation. We multiply by using this term. This is an integrating factor. So multiplying this equation by 1 divided by y cube, what we get now? You can see whenever we multiply 1 divided by, we can take y common, y cube plus 2 divided by y cube into dx plus, again here you can see that x plus 2y minus 4x divided by y cube into dy equal to 0. Then here y and y square we get, again dividing to this term we get y plus 2 divided by y square into dx plus x plus 2y minus 4x divided by y cube into dy equal to 0. Now and solution of this equation is integration of m into dx plus those not containing x containing x into dy equal to c. Then we have integration of y plus 2 divided by y square into dx plus here the term which is not contain x is 2y into dy equal to c. Here integration of this you can see that yx plus 2x divided by y square plus 2y square divided by 2 equal to c. This is the solution of this equation here. So this is the second rule. What is that rule? Whenever del n by del x minus del m by del y divided by m is a function of y alone. Now let us see the third rule of finding the integrating factor. We have here, what is a rule? If rule third, I am going to write here third rule. If m is of the form, which form? Y into f1 of x into y, and n is of the form which type? X into f2 x comma y, then in this case integrating factor is 1 divided by mx plus ny. This is an integrating factor. Mx minus n here mx minus ny is an integrating factor. This is the third rule. Let us solve this example by using this rule. What is the example? I am considering y into xy plus 2x square y square into dx plus x into xy minus x square y square into dy equal to 0. You can easily see that this is of the type y into f of xy, this is of the type x into f of xy. Then here m into x equal to xy into xy plus 2x square y square, and ny equal to xy into xy minus x square y square. Now mx minus ny equal to, you can see that this is x square y square plus 2x cube y cube minus x square y square minus plus x cube y cube. Here x square y square, and this will be 5 into x cube y cube. Therefore, what is integrating factor? Equal to 1 divided by 5 x cube into y cube is an integrating factor. So let us apply this integrating factor. You can see that this equation is x into y square plus 2 into x square y square divided by 5 into x cube into y cube into dx plus here x square y minus x cube into y cube divided by 5 into x cube into y cube into dy equal to 0. Here we can leave this 5 by multiplying everywhere 5, and here you can see that this is 1 divided by x square into y plus 2 into x 1 divided by xy into dx plus again here 1 divided by x into y square minus x cube. Okay, something is wrong here. You can see that this term this is equal to y cube, so y cube get cancelled, and here we have only x. Similarly here you can see that this will be x cube y square, and we remains only 1 divided by y into dy equal to 0. So this is my new m. What is my m? 1 divided by x square y plus 2 divided by x. So m equal to 1 divided by x square y plus 2 divided by x. And what is my n? N equal to 1 divided by x y square minus 1 divided by y. And I know the solution of this solution is integration of m with respect to x. 1 divided by x square y plus 2 divided by x into dx plus those terms of n that do not contain x is 1 divided by y into dy equal to c. Now 1 divided by x square, so 1 divided by y into integration x raised to minus 1 divided by minus 1 plus 2 log of x minus log of y equal to integrating constant c. So this is minus 1 divided by xy plus 2 log, that means a log of x square divided by y equal to c. This is the solution of this equation, log of x square divided by y. Here you can see that whenever m is of the type y into f1 of xy and n is of the type x into f2 of xy, then we have the simple term is an integrating factor, that is 1 divided by mx minus ny. Okay, so here these are the three rules of finding an integrating factor. Now friend, in the next video we will discuss about two more rule of finding an integrating factor, which convert an differential equation into an exact differential equation.